Hi everybody, this is Nick. This is the semifinal video for the GPS discipline oscillator. This is the second prototype. This one is more or less ready to go. I decided between the second prototype and the final version to replace this LDO with a buck converter to make the power supply a little bit more efficient. But as it is, it works perfectly well. This pigtail for an external GPS antenna is optional. I just wanted to show how it would look with that connected up. The three LEDs down here, the one on the right is connected directly to the GPS receiver. It indicates a 3D fix. The center one is under software control, and it shows that the GPS fix has been acknowledged by the processor. And the last one blinks at 3 different speeds. This is actually the slow speed, so right now it's claiming that it's accurate to within 50 parts per billion. Normally, if you let it sit long enough, this has only been powered up for about 20 minutes. If you let it sit long enough, it will eventually shift into the next higher, and then the highest speed, indicating lock qualities of sort of good, better, and best. And good is 50 parts per billion, better is 5 parts per billion, and best is 1 part per billion. And on the bench, it has routinely spent hours and hours and hours dialed right in that well. In fact, I've posted videos on YouTube, and they're linked in the project page, showing 2 prototypes simultaneously projected on the same scope, and you can see the one's drift relative to the other. And I've been able to see, over the course of an hour, they're time-lapse videos, so they look much worse than they are, but you have to realize that it's actually an hour of real time. And if you were to just watch the scope in real time, you wouldn't really see anything because it's that close and that spot on. But over the course of an hour, you can see it gain and lose individual cycles at 10 megahertz, which, the one video I posted was over the course of an hour, it gained 17 cycles, which is less than 500 parts per trillion accuracy. So this is going to go on my Tindy store next week as soon as the production boards arrive, which have the buck converter replacing the LDO. So as a product, it is kind of ready to go. What it still needs to be a successful product is volume. And to achieve volume, I think there's probably 2 things that are required. I have to come up with some kind of case solution for it. The production boards are going to have a slightly different spacing of the LEDs, and that will accommodate a light pipe array, so that you can actually mount the board in the bottom of a case and then drill 3 holes and then have the light pipe extend out the front, which is a lot more convenient than having the LEDs shine up. You would also then drill a hole in the left side of the case and just have the hole line up with the barrel connector, and that would be how you'd power it. And then 3 D-shaped holes on the front for the BNC jacks for the output, and then 1 final D hole on the side or the back for the pigtail. If you make the enclosure out of metal, then the internal patch antenna will probably be no good, so you probably have to always use an external GPS antenna. This is a standard U.FL to SMA pigtail, and this is a very nice active GPS antenna that Adafruit sells. Highly recommend that one. This battery here just simply is providing backup power to the GPS receiver so that it can achieve a startup, a fix after a cold start a lot faster. So that's where we are. This is ready to be a product. I am going to go ahead and probably send in the 3 prototype copies to make this a best product entry. I didn't think I'd be able to do that on time, but I think I can. Thank you very much for your consideration.